I'll never have a girl. Hello everybody, welcome again to another live on video game design. Do you like Procol Harum? I don't know its pronunciation. Procol Harum, the band from the late 60s. Hopefully, yes. So we are here with Sidereus. We are able to touch the screen and have our touch event. So let's put an alarm because I certainly played the guitar today early and then going to take a walk. Let's finish at 4 p.m. 5 minutes. Then I will play guitar for 1 hour and 20 minutes, hopefully. Then take a walk. Yes, that will do it, hopefully. Never have to come to 20. Yeah, let's do 420. 2 hours. Yes. Okay, we have 15. We have a lot of work to do this game. Whoever has the data will be able to train the algorithm. If you don't have massive data to train your algorithm. Okay, sorry about that song. It's again melodies by Procol Harum. Okay, let's get started. We oh, tomorrow we will be doing a Scala for 2 hours or 3 hours because I read the problem and it is counterintuitive using unfold. You're not recursing anymore. You're recursing, but it's kind of a different pattern. So yeah, it will be interesting. And we will see if we are able to solve the problem because there are quite lots of functions to write, several functions. Then on Friday, the hard one. Okay, let's open see those gain loop. Um, we have our gain loop, we have our byte touch. We are going to change this. Libraries. We can undo this comment. Let's use, we are able to touch stuff. We are able, you saw this. We are able to use please. Okay, so let's challenge ourselves. What's the point of let's tackle the hard, the moving the spaceship by clicking with your finger and moving. You see my finger, move the finger. Look at this, it's moving in the screen. Paint. Let's do that. We were able uh, see how it goes. All right, so we will need our MDM developer website. We should have stored those Doge event. Okay, Doge events. We have this definition. Then we have our handle move. Doge start. So they after all, this is a good example. Yesterday I said that it wasn't that you should keep these things simple, but yeah, if you like read the thing, it is a good example. And yeah, it is very good explained. I need to study mathematics. I do. I need to come up with a schedule. A schedule. That will happen today. After that, we interact with all touch objects in the list. Change touches. And in the case for moving the spaceship, it will be hard in the sense that the coordinates doesn't correspond to the canvas. Coordinates. All right, I want the touches just remove. Each time one or more fingers moves, a touch move event is delivered, resulting in our handler move function being called. Its responsibility in this example is to update the cache touch information and align from the previous position to the current position of each touch. And this is the rate, so we change touches as well, what it looks like, what it looks in our cache. So it's information array for the previous information of each touch. Let's determine the line segment. Line probability, this probability, integer result, and the main result for the generation surface. Let's get the line of the preposition. After drawing the line, we call as line to replace the variable. When the user lifts a finger of the surface, a touch event is sent. Touch and event is 300 like that function below. Its job is to draw the last line segment for each touch and remove on the from the ongoing touch list. Oh my god, this is hard. This is a hard one. Drawing the spaceship when the finger is moving, unless we decide to, so the user moves the spaceship, and the spaceship responds at the end of the movement. Then the spaceship moves, point, and moves. But if you want to draw move the spaceship while your finger is moving, I don't think it's trivial. Mhm. Take 10 minutes. We need to move the spaceship. The spaceship. How can we do this? It's hard, you know. Move, move hero. Let's see. Yes, no movement. Only clicks. That's it. You're saying the finger. Now I'm going to move, and that's the you know the event. Look at this. Nothing's happening when I click. And now I'm going to move the spaceship. Oh, boom. What is it still? And one touch. I'm not sure about that. Yeah, to see. Oh, this thing is way behind. Hopefully, you're able to see me. Going concentrate read. It's one almost deliberate something handle. Its responsibility. This example is to take a cache touch information and to download on the current location of its touch. I wanted some months ago, couple of months ago, I wanted to write an application on geometry, but now we will have the experience to do that after this game. to tackle that geometry application. That's great. It is easy to upgrade. Change touches. They're using the same. More, more. We need to tackle algorithms. This reminds me of other algorithms in place. January, March, April, June. Then, January, February. You know, this is like, this is, you know, sometimes it adds, it adds uh, elements and sometimes remove elements. So you will have to study and see when the thing adds element and when it removes elements. Yeah, sometimes elements attribution sometimes deletes elements, so even replace. So it doesn't mention when it adds elements and when it does remove elements. So you can spend like 2 hours experimenting with this. Okay. Oh, we have oh my an auxiliary function, helper function. Here it is. I can't believe all this constant n complexity. Uh, the thing is quite quick, quite fast. With this, every time you put, okay, so the endpoints are quite, it's a good application. It will help me with my geometry idea. Hello. Okay, so I'm going to click. So a point is added. I'm going to move. I think it's moving with me. Moving, 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 and lift. Message channel from and um, okay, there's still right there, which is still rectangle. Okay, this is a hard one. Why why are they uh, why are they they even need to, it seems like they are even when they are handle the end event, they are still drawing lines. So they draw line in the end event, in the move event, and in the start. This is the circle. This is I'm solving the functional programming in Scala. And this the thinking is different. This is like a more complete view of the system, um, and how to integrate several components. On the other side, about defining functions. How more or less by the was at least intermediate. Mm, I saw people stating that AI code assistant helps them to deliver more quickly, but in this scenario, how will I prompt the AI system? Will I give the code to AI code assistant and tell you're seeing the code to this spaceship and now write me a function to move the spaceship and update the render, and the AI code assistant will give me the function. Or perhaps that's the way. I'm yet to see that, and that will be amazing. To be honest, providing some code, uh, asking for some function definitions like this one, but I still there I will construct some other three pieces of software like people have been doing since the beginning. Not the beginning, from at least the 80s, 90s. Yes, 80s. Um, late 80s. Well, anyway, and then switch to AI code assistant to see what's going on about this personalities because I am kind of lost right now, especially because I am constraining myself to this example, and perhaps I need to liberate myself from this example. Actually, study the API and my own this this uh, interfaces. Let's switch to change those. Still, let's use a console. To this. Look at the number of events. Oh, it's too hard to talk. Repeat the number of events. You know, this I had a problem because what happens if the user is moving this way and then switch with this? Also, I can, I suppose I can render with at the speed of the movement if the user goes it so quick. Uh, there is a render and it goes too slow. I think I'm going with the movement, but only if the user lifts a finger, which is unnatural. You know. People want in reality, you have something, you move it, and it happens in real time. You know, there is no this, and then the thing moving. This is the natural way. You know? Well, let's see how it goes. Change touch. Okay, we have change touch. Well, I don't understand. There is only one in my case. Touches, touches, length. You are seeing only one. One. So, is this how? What's that? Will be from 0 to 1 at every single movement? You know, way to transform the spaceship coordinates to screen coordinates. Let's switch to total tab because um, we're going to use page X and page Y. It is more consistent. 480. Four hundred and eighty. Okay, we need to finish. We are going to use page. Okay, now I'm going to experiment with how fast the move should be. Mm, noticeable. Okay, let's suppose we are here. 'An average is from 75 to 90, 75 to 85, 75 to 85. 75 to 85. 75 to 85. And I was thinking, where are you? Yeah, it took like a minute. My mind went fast. Think about the past. But yeah, it's not. I was thinking other things. But now we are back to this game implementation. And yeah, we just need to transform. We are seeing the data. Where is it? If it's start with this is 85 to 95 will be the range. Say 75 to 85 will allow that will be a range. And so there are like 15. We need to determine if we're going to move at constant time, whether by 2 by 2 or 5 by 5. It's irrelevant. Well, it's relevant if you're doing like a triple A video game. But for us, we will move at constant time. Well, we need to determine if the spaceship will move to the right or to the left of its actual position. So we need to find a way to encode that information, and it's can't believe how time flies. Mm. We need to encode it on this direction. So do you like this angle the most, or the one in which the computer is on the bed and you're able to see everything over here? Okay, now this thing is at 14 x coordinate x coordinates, and this page x will be always greater than the actual coordinate. When we are here, we are at 150, and we click, so we touch the screen, and The reported page X coordinate is like 500. So we need a way to subdivide in segments all these coordinates that goes from 0 to 1000, I suppose. Let's click over here. Let's clean this. Move. Yeah, 1000. These things go from 0 to 1000. Let's, what can we do? Now we have another problem of the screen. Now it is 100 and 1500, 1500, 1500. We can look on the internet for mm, we need some mathematics over here. Okay, our spaceship goes from 0, 14. Are you able to hear? Yes. Where is this? Okay, we are able to go from. We don't care about the y coordinate because we are not moving upside down like for the level one. Someone is interested in funding this game, then we will need to come up with proper assets and the story is good, Melanco y Sidereus, and it's good. We can move from 14 to, let's use 150. Mm, okay, okay, 7, almost there. 13. That's 9. What's this? It is, it is, in order for you to see it, right? I can do it on my notebook, but no. If that's the case, what's the point of being in a live streaming? Maybe I'm going to decide to not continue with this live. Okay, we can move from 13 to 100. That's our that's our coordinates in some plane canvas. And for the screen, 0 to X, which is some screen length because you saw that it varies from device to device. Oh my God, this is like a lot of work. Let's pause. We need to detect if the spaceship is here and the user moves in this direction from here, we should we should move the spaceship, right? Because it should start from here. But that's another problem. I'm going to apply for some job. Job. The game developer, because like there's a lot of challenges in this area. Okay, now what can we do with these two like pieces of information? And we want to move in order for the thing to be visible. We will move in increases of 3. And let's add face it. Uh, 25. How can we establish a correspondence between these two lines? Well, no. Well, we will say that 0 is 13 and 200. 17, 287 is equal to x. We can, change this. If this is the case, how much? Where in the world is 25 in this line? I think I'm leaving early because I need to take a walk for an hour because I want to lose weight. And I would like to play the guitar this time around early because I don't want to be very late at night playing the guitar. I want to sleep early, go to the bed early. Besides, okay, now how can I insert this information over here? If 13 is 0 and 287 is x, much is 25. So this seems like an equation in two variables. Two allowance. How can we solve this? Again, this is a question for artificial intelligence. You put drawing at the prompt and put this equivalence. Let's try that. Okay, chat. Yeah, I agree. Okay, okay, 13 equals 0. 100 equals x. Given this equivalence, give me the value of y. It says, well, we need to determine the pattern or rule that relate the number of the single number of the right side obtained by 13. So the question, we can get y was 25. Do you believe this thing? This thing is to exemplify that if you don't know any better, machine will come up with an answer, and you will need to trust because you don't know any better. Machines will be taking decisions, and you, the human, will be Okay, if you say so, let's do it. Let's not. So this thing is saying, oh, well, let us give this thing another try because perhaps it's right. Right? Where is this thing? Okay, okay. This y equals 12. You know that we expect a number greater than 13. Let's help this AI system. Yeah, now we're talking. Yeah, but I don't know. Still, let's give a let's use this area. Okay, here it is. This is more like it, you know? Oh. You know, I don't know who is we are being silly here, right? Are you seeing this thing? We are saying that 25 were okay. 25 equals 5, and we are asking the value of 5. Do you see the nonsense over here? We are saying 25 equals y. There's nothing to solve for this machine. Look at this. 25 equals y. Still, the algorithm goes into big steps, big strides to tell us that in fact 25 equals y. So we need to state our like we need to state our problem better for this AI assistants because you see I mean how in the world are we asking about this? Let's put some number over here. Yeah, let's use 1,000. Okay, right. Still with you. This is this is great stuff. Hopefully you are enjoying this. If you are seeing the recorded version of this video and come up this far, my respects to you. You know, this is very boring even for me. Let's solve this problem because I want to have this experience for my geometry application, which is for me is like, I'm sorry about this, but it's even better than this video game. You know, like I want to engage people in mathematical thinking. Okay, so 13 is 0. Now we can say that don't worry, don't think this is a waste of time because when we get this, the problem is solved. It's just about calling some functions. The problem is this, we will also have limits on this. So if thing is getting closer to this number, any given number over here, we will stop moving the spaceship. So this is great. We need to solve this. So we're saying that. Okay, let's use this from I think elementary school. Let's say just 100. Sorry for my number. This with the mouse. Now how much? It's 25. Should be greater than 13, but for sure. Now we multiply these two. 20,000, 25,000, and divide by 220, which I'm not going to do manually because I already did a lot of this. Divided 87. Do you believe this thing? I don't, because 13, if this is 27, then 13 won't be 0. And this is all wrong, sorry, but bear with me. We are going to arrive to the answer. I'm just wandering around. Mm, 5, 57. Forty-five. Yes. 5. 19. Mm. So in this scale, the zero is 0.25, a quarter. The relation goes like this: one quarter, almost one quarter of this number. We need to establish the upper lower limit. I think tomorrow I need to wake up early in order to tackle all the things that I want to, because today I did wake up early of 8 o'clock or 7 o'clock, but I start later with these live sessions. So tomorrow for sure I will start early. Perhaps this will be the first session tomorrow, very in the morning, but I won't be able to talk, like be talking like this, because there will be people sleeping, and but you will be seeing all the process in the screen. Whenever I have a problem, encounter some kind of obstacle or challenge or an issue to be a problem to be solved, I will try to write it on the screen so you are seeing the entire process and don't miss anything of this video game implementation. So you can see if you are looking for information, like I was looking like many years ago. Uh, so you can see how a video game, some simple video game, is implemented from zero, and all of the things that are coming up in the process. There is a lot of articles out there. Hopefully, this is helpful to you if you're watching this in some kind of future. And well, again, most likely you will be asking to an AI to implement a video game for you. But if you want to do it manually, hopefully you find this video and hopefully helpful to you. Probably I should be done this in Spanish because I want, you know, for Spanish speaker also to see that, like Hideo Kojima. I saw this video game producer. He doesn't talk any English, and he talks Japanese. He understands English for sure, uh, but they always have a translator. So the most important thing is the products. Then you can ask for a translator if you're in need to speak English. But other than that, speaking English is, or any other language, natural language, is learning. It's always a good idea. But this all is to avoid thinking, to be honest, and to recognize I need to start early in the morning to achieve all the stuff that I want to accomplish in a given day. That's is a reality. I need to start very early in the morning, like my grandfather and my father used to do. I need to replicate that behavior, to live on the standard that they set up with their lives, with their examples, and in the night be able to say, well, today I did this, and I am unashamed of because I didn't waste any time wandering around. Those people were like, I don't know, I should learn more from them. I really, oh my God, I need to start. Uh, t- Tomorrow will be a good day for me to start exercising their example, at least in that area, because those were very strong people that I always will always admire and try to emulate. But I'm not sure if I will be able to live to that standard of super hard work. But I'm going to give it a try and try to be constant. And I will have to say goodbye to you for now. Don't worry, I won't solve this on my own, or tomorrow we will arrive to the same point. You will see, and probably spend the entire day with this problem. But the reflection that I just did, was a good one. It is a necessity for me. If you are like struggling, hopefully this serves you as an example. There's no, like no secret bullet, but to be consistent on what you do. Perhaps later you will be seeing me doing some Scala. I'm not sure. I'm not sure. Yeah, goodbye, bed. We'll start waking up early. Uh, I mean, I wake up every 3 weeks, 3 days a week at 3:30 a.m. because I go with my mother to the hospital. So when we stay, we need to rest and be able to wake up at 7 in the morning, 8, because we are always very early most of the week. But I don't know. I don't know. I don't want to wake up at 3:30 in the morning every day, but perhaps that's the only way in which I can be consistent with my cycle, living cycle, sleeping cycle, living cycle. I will have to like go to the bed at 9 p.m. and we'll see. I will have to do it. So the old Caleb will be in the past. And that will be like the best version of me, I suppose. I don't know. You like that? Well, most likely see you. Well, see you later for those of you following the Scala videos. Those are challenging functions that are coming up in the problems. And If you're only following this series, well, see you tomorrow with this in this same spot. I won't be. Well, perhaps if I go and take a while, perhaps I will think of this problem. I don't know. Hopefully not. But it will be a good idea. But this is the first time I do this. Try to this conversion. 10 minutes for 4 p.m. and we set up the alarm. So we have half an hour. But I really want to play the guitar for more than an hour. I always rushing practicing. That's not good. I have to take my time and enjoy every single pick, stroke, the drum, pick. Yeah, this is a good one. I'm thinking computationally here. That's why I am a little bit out of computing and more into mathematics because in here I am thinking computationally in the sense that if 13 is 0 and the 100 is 10,000, then this, if you are an expert or I don't know, you probably know and see, start thinking, my God, this is so obvious, but it doesn't. It isn't. Only when you're uh, if you continue to practice, then it is obvious. But at the beginning, nothing is easy. We'll see. I don't want to wake up early. Not that early. But I do it 3 days a week. Uh, how can we solve this thing? Maybe in terms of ranges. Uh, how can we find the midpoint of these two? Let's erase all of this. Let's see. Let's find the midpoint of this line. How can we find the midpoint of this line? Yeah, 200 minus 13. Is this the midpoint? This is like algebra, you know, geometric analytic. Oh, 77, 77 minus 374 divided by 2. One Yeah, yeah. Okay. Mm, the 500 is this one. Um, this is like the midpoint. So this should be here. How can we find a correspondence between these two lines? Okay, let's you know the past if you solve some triangles. Oh my god, this is hard. Now let's put this. Thing. It should be 1,000, but let's go with this nonsense. Like the right is right too. This is wrong. This is wrong. This is wrong. Yeah, bear with me. Let's think in terms of similar triangles. 5, 3, 4. Um, Now this we'll find this x, and we will find this y. So mm, remember 5/10 equals 4/x. And equal 5x. So these things is right. We established this proportion. Now let's suppose how this line, we need to think of how this line is defined. Well, this line is defined as a 0. Yeah, it is like contained, the point is contained. There's a range of numbers. 5. Okay. So how do we take the length of this line? We say this is A. If I am overthinking this, please, sorry. This is B. Still, I'm missing the, like uh, something. I'm missing something with this relation. So instead of putting this 5, we will put 5 minus 0 over 10 minus 0. Mm, 4 minus 0 x. So for us, it will be 200 Colorado 2 minus 13 over 1000. We can leave that alone. It was 207, 77, 77 minus 3, 74. Times equal 25 minus 13, 12 times 1000. Just this divided like this. Forty-three, 43.79. I don't think this is correct, but perhaps it is, because 30 is 0, so 25 is 43. These are very close, you know. 13 to 25, there are only 12 units in reality, and in here they are 43 units. How can we test? Uh, Maybe 100, 13. This we will test with the endpoints. 13 13. 13 minus 13 is 0 times 1000. This is a good way to solve this problem also, because if this thing is 13, like this, 13 minus 13 is 0 times 1000 is 0. So this means this will, like this will be 274. 274 x equals 0. And if we use 277 here, 287 minus 13, 274. Oh my God. Times, you know, but we need, this will be 0 x. There won't be any x. So the number will be like 274, 200, 280 minus 13 times 1000. This is so wrong. If we put in here, sorry, there's something wrong with the 180 minus 13 times 1000 divided by, yes, this is more likely. Yes, this is it. Because we are now like very close to 1000, because we use 280. We use 185 minus 13 times 1000. And we are arriving to 1000. So this is the answer. This is our equivalence. Well, we are going to continue tomorrow. We find the equivalence. Now if we have any given point in which the spaceship is located, we could solve it. You know, if you have any given point in which the space is located, we can use this formula and find its equivalence in this line, so we can know that we can then we can know if the movement is happening and if the movement coordinates happens very over here, like a very large number, we can use this and this formula to see if there is some closeness. And if it happens over here, like we just did in the calculator, 992, our spaceship is here, then we don't move anything. If nothing happens, if it is, if the coordinates are like in 43, um, in a close, some closeness over here, it won't be precise at this point. Then we can see, okay, we are going to move the spaceship. Now to determine the direction, we need to see if the upcoming coordinates are like uh, uh, greater or less than. We can avoid all of these calculations by putting some controls over here, like some video games that you, of course, have saw in this left corner. We can place some buttons and assign some coordinates. And if the user player, use the finger to move, it will be easier. That's the easy way out. Placing the controls over here. And of course, that will be insanely easy to just move the spaceships according to this control. It will be obvious if the user wants to be to the left or right, to the left or to the right, but that's the easy way out. And let's give it a try to move this spaceship with the finger. And if it results too hard, then we certainly can go back and use some controls down below the corner. Over here, whatever you like. It's not important. Well, it's important, but not right now. But let's give it a try for 2 more hours to move this thing. And if it resolves on some silly effect, then we can certainly go back to these controls. But that will happen tomorrow. Today we actually exhausted the time, 2 minutes. So thank you very much. 2 hours. Thank you very much. This was very enlightening for me. Talking out loud, knowing myself a little bit better, making plans, public plans, so I can commit those plans. And yeah, we will continue tomorrow early in the day. We are starting tomorrow, waking up early. It will be hard. Uh, let's give it a try. Let's give it a try. It will be very hard. It's another lifestyle, going to bed at 9 p.m. But let's give it a try. Thank you very much. Bye.